In this video, we're going to predict the winner of the World Cup Qatar 2022, and we're going to use Python for this. We're going to use the pandas library, and also we're going to use SciPy to import the Poisson distribution. So let's get started. Okay, to start with this video, we have first to import pandas, pickle, and the Poisson from SciPy. So to do this, first we have to install these libraries. So in case you don't have any of them, you have to write pip install and then either pandas or pickle or SciPy. So if you're in Jupyter Notebooks like me, you have to write this exclamation mark, and if you're on any other IDE, you have to open the terminal and run this command, pip install and the name of the library. Okay, once you have the libraries installed on your computer, we have to run this, and we successfully imported these libraries. Okay, now for this video, we're gonna use this CSV file. We're gonna import this CSV file and we're gonna read it with pandas. So let's have a look at the CSV files. First, we're gonna use the dig table. Actually, this dig table, I web scraped a website to get the tables of the groups in the World Cup, and then I exported these tables with pickle, and now I'm reading this table again with pickle. So all these files, this dig underscore table and these two CSV files are going to be in the description, and you can download. These files. Just for the record, we extracted this data in previous videos. So if you are interested in learning web scraping and how to extract this data on your own, you can watch those videos. But if you're not interested in that, you can just download these files, and these files has the clean data and you can read it in with these lines of codes. Okay, so now then we have the clean FIFA World Cup matches, and basically this has the data from the World Cup 1930 to 2018. So we have all the historical data, all the matches played in those World Cups. And finally, we have the World Cup fixture. This is the fixture of the World Cup Qatar 2022. And now we can read all this data and have a look to this data. So I'm gonna show you first the dig table, and this one has the groups as I said before. So we have the tables, and right now it has only the value of 0 in each team, because we haven't run any model to predict who is going to be the winner between the matches that are going to be on the World Cup, but we're going to take care of that later. So we have here all the groups from group A to group H. Okay, then we have the historical data, as I said before, from the matches from 1930 to 2018. Okay, then the fixture of the 2022 World Cup, and this is the fixture. Okay, now let's see the next thing we have to do, and here we have to split the data frame historical data into two data frames, home and away. And to do this, first I'm going to show you again this data frame, and here we have this data with all the matches, and what we have to do is to split this into two. So we have to write, for example, df home. This is the one of the data frames, and this is going to be equal to df historical data, and then we have to select only some columns, and the columns that we're going to select are the home team, then the home goals, and then away goals. So 3 columns, and we're going to do the same for the other one, for the away team. So I write df away, and then away team, then home goals 2 and away goals, and that's it. So with this we have these two data frames, and we can run this. So we ran these lines of code, and then for the next step we're going to rename some columns. So I'm going to show you the name of this data frame, the content of this data frame actually, and this is the content. So we have the home team, home goals, and away goals. And now we're gonna rename some columns for some particular reason, and I'm gonna explain you right now. But first I'm gonna write rename, which is the method that allows me to rename a column, and then write the column parameter, or actually columns. Then I open a dictionary and we can rename any column we want. In this case, we're going to rename the 3 columns that we have here. So first home team, and then home goals. So I'm going to write here first the original name, then this colon, and then the new name. So instead of home team, I just want to name it as team. Then we have home goals, and I want to name this as goals scored. So I don't care if it's from the home or the away. I just want to name it as home scored. Actually, goals scored, sorry. Goals scored. And for away goals, we're going to name this as goals conceded. So I'm going to open this quotes and then write goals conceded. So we have team for the home team, then goals scored, and then goals conceded. And this is basically because when the home team scores a goal, those are the goals they scored. And when the away team scores a goal, for the home team, those are the goals that the home team concedes. So that's why I wrote here goals scored and goals conceded. So that's the reason why I'm writing this. Then we're gonna do the same for the away data frame, but in this case, I'm gonna write df underscore away. Now rename, and here away team. So it's something like this. And then we're gonna use again team instead of away team. And then here, there is something that you have to keep in mind. Now we have to be in the point of view of the away team because we're in the away data frame. So the home goals for the away team are like goals conceded. So I'm gonna write here goals conceded. So every time the home team scores a goal, for the away team, that's a goal conceded. And every time the away team scores a goal, for the away team is a goal scored. So this is kind of the opposite of the previous one, which was from a point of view of the home team. So this one was from the point of view of the home team, and the last one is from the point of view of the away team. And now we have a standard column names, and this is going to help me for the next step. So here I'm going to update these values by writing here df home equal to this, and df away df away equal to this. So with this we have some standard names for the columns, and now we can continue. So I'm going to run this, and now what we're going to do now is concatenate again the home and away. So we're going to have again our historical, something like our historical data, but now it has a different structure. So when we concatenate the home and the away data frames, we're going to build the team strength. And basically this team strength is going to be the foundation for this prediction. So I'm going to show you here so you understand much better what I'm trying to say. So I use pd concat to concatenate 2 or more data frames, and then I'm going to use df home here first and then df away. So these are my 2 data frames. Then I'm going to add the ignore index parameter and set it equal to true because I want to ignore the original indexes from the 2 data frames. And then I'm going to group by team. And after we group by team, I want to get the mean. And we get the mean because I want to get the mean of the goals scored and the goals conceded. So we can see the strong points and the weak points of each team, or in this case, each country. So this is what we're gonna do. So if I run this, now we can see that we have all the teams listed, or all the national teams listed, and we have the average of goals scored and goals conceded. And this is good because now we know how good is a team or how bad is a team. So for example, we can see here Argentina has 1.69 of average in goals scored and 1.14 in average for the goals conceded. So we can see that they score a good number of goals, but they don't concede so many goals. So this is going to help us when we, for example, we have a match. I don't know. We have a match Argentina with Mexico. So based on the goals scored and the goals conceded, we can predict who is going to be the winner. So this is our basic prediction that we're going to do with Python and with the Poisson distribution that we're going to see later. But for now is enough. So I'm going to name this as df underscore team underscore strength. So I run this, and now, well, copy, paste, and now I run this. So I run, and well, we have this data frame, which is gonna be the base for my prediction. So now that we have this data frame with the goals scored and goals conceded, what we have to do is create a function that predicts how many points one team is gonna get. So we have 8 groups in the World Cup. Group A, B, C, D, until Group H. So in each group, we're going to have many matches. And after one team wins a match, that team gets 3 points. If the match ends in a draw or a tie, each team gets 1 point, and if the team loses, the team gets 0 points. So we're gonna create a function that gives some points to each team based on these goals scored and goals conceded. So we're gonna do this here, and actually I already have the function because there is a lot of code here and I don't wanna build this from scratch, but I wanna explain you what this means step by step. Okay, to predict the winner of the World Cup Qatar 2022, we're gonna use the Poisson distribution, and well, we have to implement the Poisson distribution here in Python, and this is all the code. But before explaining you all this code and what each line of code means, what I'm gonna do is explain you about the Poisson distribution, why we're choosing the Poisson distribution, and the application that we can use in football. So that's more important because we can write code, but if we don't know what we're doing, we don't know the statistics or the math, we won't be able to understand how we're solving this problem. So let's check the foundation here, which is the Poisson distribution, and let's go here. So here's the Poisson distribution, and the Poisson distribution is a discrete probability distribution that describes the number of events occurring in a fixed time interval or region of opportunity. And if we apply this to football, we can consider a goal as an event that might happen in the 90 minutes of a football match. So a goal can happen in the 90 minutes of the match. We can have one goal, no goals, or 3 more or more goals. And that's our event. So this event happens in the 90 minutes of a football match. So this is a fixed time interval because a match has 90 minutes. We can have some extra time, like 3 more minutes or 5 more minutes, but we know for sure that every match at least will have 90 minutes. So that's the idea that we should keep in mind. Alright, now before we choose any distribution, we have to make sure that we're following the assumptions that these distributions have. So for the Poisson distribution, we have 4 main assumptions. And the first one is the number of events can be counted. And in this case, if we consider an event as a goal, then we can say that we can actually count the number of events because we can have 1 goal, 2 goals, 3 goals in a match, and we cannot have 1.5 goals or 3.5 goals. So we can say that we can count the number of events. In this case, we can count the number of goals. So number 1 is correct. Then we have the second one, and the second one says that the occurrence of events are independent. And this one also, our project follows this second assumption because the occurrence of one goal does not affect the probability of the occurrence of another goal. So we can say that 2 goals are independent. And well, in this case, it's arguable that that maybe if a team scores 1 goal, that can motivate the other team to go and score 1 goal. So the match will be 1-1, for example. So that's arguable, but to make things simple for this project, we're going to assume that one goal is independent from another goal. Okay, then we have number 3, and it says that the rate at which events occur is constant. And basically this means that the probability of an event occurring in a certain time interval should be exactly the same for every other time interval of the same length. And we can say that this one is also true, because in a match, the probability of a goal in one match is the same probability of the goal in another match. So if we evaluate the probability of goal in different matches, we should have the same probability. So this one is also fine. And then we have the last one that says that two events cannot occur at exactly the same instant in time. And this one is also true, because in a football match, we cannot have two goals at the same second, at the same time. So we have one goal, and after, I don't know, 5 seconds or 10 seconds or 1 minute or 10 minutes, we have the second goal. But we cannot have two goals at the same time. That's impossible. So with this, we see that we successfully follow the 4 assumptions. And now let's see the Poisson distribution. So here's the equation of this Poisson distribution, and the main input is the lambda. So the lambda represents the expected number of events per time interval. And if we consider our project here, our football project, we can say that lambda is the median of goals in 90 minutes. So in this particular case, I'm gonna have 2 lambdas. Lambda for team A, or for the home team, and lambda for team B, or lambda for the away team. So we're going to have 2 lambdas, and then we have the x, and the x represents the number of goals in a match that could be scored by team A, or the home team, or team B, also known as the away team. So a match, for example, can be like the final score 3-2, and we have the x for the team A, which is 3, and the x for team B, which is 2 in this example. Okay, now that this is clear, let's see how to implement this Poisson distribution equation in Python. So here I have the function that I created, and I'm going to explain you right now. But before this, to use the Poisson distribution, we have to import it here from SciPy. That's stats, and we import Poisson. So here we can use it, and actually I'm using here Poisson to calculate this equation. So instead of doing this equation manually, we use here the Poisson function. And okay, let's have a look at the function that I created, which I named predict_points. So this function is gonna get the name of the home team and the away team, and it's gonna return the points that each team receives. So now, after we define the input and output, here I have a condition. So I write if the home team is inside this data frame, df team strength, which is this one. If this home team is inside here in the index, and if the away team is also here in the index, then we can calculate the lambda for each team. And this is something that we have to keep in mind, because here the names have to be exactly the same as we have it here in the index. And we're not going to have any problem, because the names of the data frames, the different data frames, have the same name. I just mentioned this in case you want to try it yourself. When you write it on your own, the name of the country, it has to be exactly the same as we have it here. Okay, now after this condition is true, we calculate the lambda. And as I mentioned before, we have 2 lambdas. 1 lambda for team A, or the home team, and 1 lambda for team B, or the away team. And the way we calculate the lambda might change. In my case, I did it in this way. I multiply the goals scored with the goals conceded. So this shows how it's like it shows how many goals a match can have, and it's based on the goals scored and the goals conceded. So the goals scored by the home team, in this case home, and the goals conceded by the away team. So let's have a look at lambda home. So we select the from the team strength, which is this one, we select the goals scored. So this is the average. So here, as you might remember, we calculated the average goals scored and the average goals conceded. So we have the average goals scored by the home team, and we multiply this by the average goals conceded from the away team. So we multiply this and we get a value, and this value represents lambda. And the same goes for the away lambda away. So it's the same, but here we have away, the goals scored by the away team and the goals conceded by the home team. So you can see that the more goals the team scores, it makes lambda bigger, and the more goals the other team concedes, it makes the lambda of the team, the first team, bigger too. So it's a way to benefit those teams that score more goals and to penalize those teams that concede more goals. And that's basically how we calculate lambda home and lambda away. Then I create three variables: the probability of home, then prop away, and then prop draw. And I set this equal to 0 to start from 0. And then here I do two for loops. So these are the simulation of the match. So I'm using a range from 0 to 10, and I'm saying that a match can have only between 0 to 10 goals, and I'm simulating each score. So for example, 0-0, 0-1, 0-2, 0-3, and then I'm doing the same with the opposite, with the now in benefit of the away team. So 1-0, 2-0, 3-0, 10-0, 1-1, and so on. So I'm calculating all the possible scores, and I'm using here the Poisson function to calculate here this equation. So I'm replacing lambda here with lambda home and lambda away, and then x is going to be here the number of goals. So x here, the number of goals of the home team, and y the number of goals of the away team. And that's how I calculate the probability. So I have P that represents the probability. And now then we have three scenarios. So we can have, based on the score, X and Y, we can have three scenarios. We can have a draw, we can have the winner, the home team, or the winner, the away team. So those are three scenarios. That only three scenarios that can happen in football. So if we have a draw, so if the score is, for example, 1-1, then we're gonna accumulate the probability. So here we have the probability that we calculated, and this probability is gonna be added only to the scenario that it corresponds. So if the score here is x1 and y1, then x is equal to y, and then the probability of draw is going to be this p. But if, for example, the score is 1-0, then x is greater than y, then the p is going to be equal to probability of home. And finally, if the x is less than y, for example, we can have 0-3, then we're gonna this p is gonna be equal to the probability of away, and this is gonna be accumulating for each simulation. So we're gonna add we're gonna simulate each score, and then we're gonna add to the scenario that it corresponds, and that's how we're gonna get the final prop underscore draw, prop underscore home, and prop underscore away. And with this, I created here a formula to find the points home and the points away. And this formula is easy to understand if you think of a scenario where the probability of home is 100% or 1. If this is 100%, then the home team wins, and then 3 multiplied by 1 is 3. And then if this is 1, so if the probability of home is 100%, then the probability of draw and the probability of away is going to be 0. So 3 multiplied with 1 is 3, then plus 0 is 3. So we have that the points of the home team is 3. And that makes sense because when a team wins a match in football, they get 3 points. When it's a draw, they get 1 point. But when the team loses the match, they get 0 points. So this makes sense. And in case of the probability of draw being 100%, then we have here 1. And then this one is going to be 0, the probability of home. So 3 multiplied by 0 is 0. And then we have here the points home 1. And again, makes sense because when it's a draw, then we only get 1 point. And the same goes for the points away. It's the same idea. So here, after we calculate the points home and the points away, we return this inside the tuple. So this tuple has the points home and the points away. And in case this condition is not true, so this one is false, then we're going to return here a tuple that has only the values 0 and 0. And this might happen even with our data that is correct. So I'm going to explain you why. But to explain you why, I'm going to do some examples here. I'm going to test this function. So here I'm going to run this. And now let's see why we sometimes might get 0 and 0. Actually, it's not sometimes, it's only once for one particular team or country. So let's test our function first, and then I'm going to explain you. So by testing our function, we also will see what this function means. So we can write predict underscore points, and then let's write the first team, which is Argentina and Mexico. They are in the same group, so it makes sense that I run this. So I run, and now we get this output. And what this means is that if Argentina plays with Mexico, then Argentina will get 2.3 points and Mexico 0.5. So there are 3 points available. That's the maximum number of points a team can get. And if Argentina plays with Mexico, from those 3 points, Argentina will get 2.3 and Mexico only 0.5. And besides the points, that also represents how powerful is a team compared with another team. So that's another way to say it. And now let's see another example. So in this case, I'm going to write England and United States. So that's another match that I think is in group B or in another group. I don't know. Then we have the result, and it says that if England plays with the United States, then England has more chances of winning the 3 points than the United States. So now let's have a look now with Qatar and Ecuador, which is the first match in the World Cup. And here we're going to see something interesting. So let's write Qatar and Ecuador and now run this. So if we run this, we get 0,0. And this happens because here Qatar is the only team in the World Cup that is participating for the first time. So we don't have historical data of Qatar in the World Cup. So that's why we cannot find Qatar in our DF team strength data frame. So here in our index, we don't have Qatar because it's first time in the World Cup. So we cannot create data or use some friendly matches to include it here in this data because it won't be the same matches played in the World Cup with friendly matches or with any other competition. So that's why I thought that much better is just to ignore Qatar. So Qatar is going to be the only country or the only team that is going to be ignored in this analysis. So any team in the group stage that plays with Qatar, both teams are going to get 0. So for example, Qatar, Ecuador, both get 0 and the other teams are going to get 0 too. So in this case, the only team affected is going to be Qatar, but the other 3 teams are not gonna be affected. So now, with that clear, we're gonna continue with the prediction. Okay, now we're gonna start with the prediction, and to do this, first we have to split our fixture. So here we have the df underscore fixture that we haven't used so far, but we're gonna start using to make our predictions. So first, I'm creating different data frames, and I'm splitting this into the group stage that has 48 matches, then the knockouts, the quarterfinals, semifinal, and the final. And this helps me better organize all of this data. So I'm gonna run this, and by the way, I'm using the copy method to create an independent copy. So I run this, and now we have these data frames. For example, here we can see the 48 matches if I run here. So the first one is Qatar with Ecuador, and the last one is gonna be, let me see here, Cameroon with Brazil. So those are all the matches. Great. Now let's continue here, and now we have to run all the matches in the group stage and update the group tables. So we're gonna simulate all the matches that are gonna be played in the group stage, which is here. So all the 48 matches are gonna be simulated here below. And to do this, I just copied and pasted the code that we're gonna use, because there are a lot of code and it's gonna take me a lot of time to explain you this from scratch. But I'm gonna explain you right now what it means line by line. Okay, first here, I'm doing a for loop here in the dictable dictionary. So as you might remember, this dictionary has all the tables of the WordCap. So I can do here a keys to see all the keys. And now if I select a group, you can see that we have the tables. So let me show you here. And here we have the tables. So now we have all the teams, they have 0 points because we haven't simulated the matches. But now let's simulate it. And to do this, first, we have to get the names of each group. I mean, the names of the team of each group. So to do this, we have to write the name of the group, and then we have to select only the column we want. In this case, the team name, or the team column, sorry. We have to select the team column, and then with the dot values, we're gonna get the team names. So if I print this, let me print it. We're gonna see that we get the names of the team separated by groups. So for example, group A has Qatar, Ecuador, Senegal, and Netherlands. Then we have group B, group C, and so on. So now we have the names of the team separated by groups. And then we're selecting these groups, or actually we're selecting these 4 teams from our 48 matches. So here we have the 48 matches, and we're using here the is-in method to filter only those 4 teams. And why I do that? Because I want to get only the 6 matches that every group has. So every group has, for example, group A has 4 teams, and these 4 teams in total have 6 matches. So we have a match between team 1 and team 2, then team 1 and team 3, then team 1 and team 4, that's 3 matches, then team 2 and team 3, that's 4, then team 2 and team 4, that's 5 matches, and finally team 3 and team 4, those are 6 matches. So every team is going to play 6 matches, and I want to separate them. So that's why I create this df underscore fixture underscore group 6. So that represents the 6 matches that each group has to play. And then I use the iter rows to iterate through each row in this new data frame that only has the 6 matches. And then I choose the home team and the away team. So right now I have the right matches in each group, and I can make my prediction. So I do all of this just to avoid making some unnecessary simulations. Because, for example, we cannot make we cannot have a match between Argentina and France, because Argentina and France are not in the same group. So it's impossible in the group stage to have a match between Argentina and France. So if I split this into groups and only have the matches that are going to happen inside each group, then I can just simulate those matches that are going to happen in reality. So with this, I have the prediction, the predict underscore points function, and then I write the home team and the away team. Then I get the points of each for each team, and then we can add the points in the table. So here we use the dig table, and we use the log method to locate the home team and also the away team. And we also locate the PTS column, that stands for points, and we add the points of the home team to this value, which right now is 0, and we add also the points of the away team of this value, which is 0 too. And we do that for every match that is going to be played. So after that, we're going to do some little changes to the final table. So first, we're going to sort values by points, by the points column, and then we're going to sort it in descending order. So ascending equal to false. And then we're going to select only the team and the points column. Then we round to 0, and I do this to have integer points. So we don't have here, for example, if I comment this out, you can see this. So we don't get 2.23, but we get only 2. And here we don't get 0.59, but we get probably 1. So we get integer numbers, because it's very weird to find a team that has like 1.3 points, because that doesn't happen in reality. So with this, we have our final table, and now I can run this. So if I run this, we successfully simulated all the matches in the group stage. So now I can show you each table. So we're gonna see the final table for each group. So I write dig table, then group A, and we can see that in group A, the Netherlands and Senegal are going to be the first and the second respectively, the second teams in this group. So now if we write group H, we see that Portugal and Uruguay both make it to the next stage, which is the knockouts, and we can check every table one by one if we want. But now what I'm going to do is check out the knockouts, the knockout stage. So here I'm going to run here df fixture underscore knockout, and as you might remember, we created this before here from our fixture data frame. And I run this because here we have to update the winner of the group, so the first team, and the runners up, so the team that was in second place. And we get these values from our dictionary, because our dictionary right now has the final table for each group. So we have, for example, for group Z, we have that Argentina is going to be the winner of the group Z, winner of group Z, and then Poland is going to be the runners up. In this case, Poland runners up of group C is here. So we have it here. So we're going to update the values of the knockout data frame using the final results in the dig underscore table. Okay, now to update this table, we're going to do a for loop here. So we're going to loop over the dig underscore table. So I have this table, and this is a dictionary. So I'm going to write for group in dig table, and then we can get each table here. And we want that because we want to get the winner and the runners up. So I write dig table, then group, and we can locate the winner, which has index 0. As you can see here, the winner has index 0 and the runners up with index 1. So we have to locate also the name of the column, which is team. And with this, we have, for example, in this case, log 0 and team. We go to 0 and column team. We have Argentina in this example. And we do the same for the second one. But first, I'm going to write here group underscore winner. Then copy and paste it here. And in this case, it's going to be runners up. So I'm going to copy this and I'm going to paste it here. Now underscore and R. So now we have this, but in this case, it's not gonna be 0, but 1. So 1 represents the team that ended in position 2. So here we have 1 and then team. And in this case, we will have, for example, Poland in this example. So now we can continue and let's continue by replacing the names here. Instead of having winners group A or winners group C, now I want Argentina in this example for group C, for example. So to do this, I'm going to write the name of this data frame. I press enter and then I use the replace method. So I open a dictionary now and I'm going to write for example here winners group C. So this is the string I want to replace, and now the variable that I want to replace with, so group winner. And now I press comma and we do the same for the runner up, in this case runner up group C. And now I'm going to replace this with the runners up variable. So that's it. Then I write in place equal to true, and that's pretty much it. But with this, we're only replacing one row. In this case, winner group C and runners up group C. So 2 rows. And that's not something we want. We want to replace all of them. And to do this, we have to add the F string. So the F string allows us to include a variable inside a string. So instead of writing group C, here we can write group. And the same goes for this one. We can write group. So with this, we're gonna replace all the values that you can see here that has the words winners or runners up. And that's it. Now to finish this, after we update all of the values, I'm gonna create a new column. And in this column, I'm gonna name it first as winner, and in this column I'm gonna set this column equal to question mark, and this question mark represents that we don't know who is the winner of this match. So we don't know the winner of the match, and that's why we write this question mark. And now I'm gonna show you this. So I'm gonna run this code, and now we have the DF knockouts updated. So we have all the values here, for example, Netherlands, Wales, Argentina, who was the winner of Group C, with the runners-up of Group D. So we can check it out just to verify if everything is okay. And we see that the runners-up is Denmark. And yeah, it's Argentina, Denmark. So we have all the values here updated. But here in the winner column, we still don't know who is gonna be the winner. And to do this, to know the winner of this match, we're gonna create another function. And this function is gonna be based on the previous one that we had here, which was the predict points. But instead of having now the points of the home team and away team, this new function is just going to return the name of the winner, either the home team or the away team, but not points anymore. So we're gonna see the winner. So now I scroll down, and here is the function that we're going to create. And now let's create this function. So I'm gonna name this function as get underscore winner. And then I'm gonna write the name of the input. In this case, this function is gonna receive a data frame named df underscore fixture updated. So basically this is the fixture updated. For example, here, this is the fixture updated for the knockout. And well, we have this data and we have this question mark for the winner column. So this is the name of the input. And now we're gonna do a for loop inside the fixture updated. So we write for I in df underscore fixture updated, and we're gonna use the either rows. So we're gonna loop through each row inside the data frame. Then I write the colon, and now here instead of I, now we have two values, the index and the row. And now we can get the name of the home team and away team using the row that we have here. So we write row home, then we add the comma and row away, and that's it. Now we can have we can assign this to a variable named home and away. And now that we know the names of the teams that are gonna play, we can use the predict function that we created before. So is this one. Let me copy the name, so it's predict points, and we can use it here in our new function. So I write predict points, and we have the name of the home and the away team. So as you might remember, this function returns the points of the home team and the points of the away team. And now that we know the points of each team, now we can make a condition, so we decide who is going to be the winner. So I write if point home is bigger than points away, then create a variable winner and set this equal to home. So if the points of the home team is greater than the away team, then the winner is going to be the home team. However, if that doesn't happen and the points home is less than the points away, then the winner is gonna be the away team. And that's it. So with this, we calculate if the winner is the home team or the away team. Then we have to update this. So we write df fixture underscore updated, and then we use the log function. So we write here index, because we have the index of that row. As you might remember, we're using the either rows. And then we locate the winner column. So this column that has the question mark. And we're going to replace the question mark with the name of the winner that we have it here. And that's it. Now we can return. So I write here return. And now I write the name of the df fixture updated. And that's pretty much it. Now with this, we can calculate the winner. I run this, and now we can get the winner of these knockouts. And we only have to write get winner, open parentheses, and then write the name of the data frame, df fixture knockout. So we run this, and now we can see the winners of each match. So we can see, for example, that England will win the match against Senegal, and Brazil will win the match against Uruguay. So that's how we calculate the winners. And now to continue with the predictions, we have to go to the quarterfinals. So we have the winners of the knockouts, and now we continue with the quarterfinals. And now we have to update the table that has the quarterfinals, because here, if I write, I don't remember the name of this data frame, so I'm just gonna copy df underscore fixture underscore quarter. So if we run this, we're gonna see that we still don't have the names of each team. We only have winner match 53, which in this case is gonna be Germany, and winner match 54, which is Brazil. But we don't have this table updated. So we have to create a function to update the tables. And I have this function here. So I'm not gonna write this from scratch, but I'm gonna explain you what this means line by line. Okay, I named this function update underscore table. And this function has two inputs, the fixture of the round 1 and the fixture of a round 2. So basically, this is like the, just to give an example, this is like the fixture of the knockouts, and this is the fixture of the quarterfinals. Then we'll have the in the next stage, we'll have like the fixture of the quarterfinals on the left for number 1, and the fixture of the semifinals for number 2. And for the next one, it's going to be the fixture of the semifinals for number 1 and the fixture of the final for number 2. So that's how we can update the table based on the results of the previous stage. Okay, now that this is clear, what we have to do is do a for loop in this fixture of round 1. So we use the either rows again, and now we get the winner of the match. So we use the log method and we get the winner. And then we also get the name of the match, because as you can see here, we need to know who is the winner of match 53 or 55. So we need to know the identifier, and the identifier is in the score column. So the score tells us the number of the match 58, 57, 60, and so on. So that's why we get it here. And after we get the winner and the number of the match, what we have to do is in the fixture of round 2, we have to use the replace method. So we're going to replace anything that says winner with any match, 55 or 56, and we're going to replace this with the actual winner, so the variable that we have here. Then we set here in place equal to true to update the changes, and we again create a winner column, and we set this equal to question mark, and then we return this final fixture, so with the data updated. So this is the updated table, and we're gonna run this, and now we have the fixture updated, but now we need to apply it to the quarterfinal, and we have to write here the fixture of the knockout. So if we write here round 1, which is knockout, and then we write here round 2, which is quarterfinal. I'm gonna copy here, so I have quarter. So if we write here knockout on the left and quarter on the right, and we run this, now we have that I got an error because I didn't write the name of the function. So here is the name of the function, and then fixture knockout, fixture quarter, run again, and now we have the fixture of the quarterfinal updated. So we have the matches. We know now that Germany is going to play with Brazil, Netherlands with Argentina, Spain with Portugal, and England, France. And now we need to know the winners. So we can use the get winner function to get the winners. So here I write get winner, I write fixture quarter, and we're going to replace the question mark with the actual winner of this match between Germany and Brazil, for example. If we run this, we now know that Brazil is going to win the match, then Netherlands, then Portugal, and France. So now let's predict the results for the semifinal. And to do this, I'm going to copy here and this one too. So first we update the table. In this case, it's going to be quarter for the first input, and for the second is going to be the semifinal, which I believe it's only semi. Just in case, I'm going to check this out. Yeah, semi, and the last one is final. So here is semi, and I'm going to run this for the semi-final. And now we know that the match is going to be between the Netherlands and Brazil, and then France with Portugal. And now if we want to know the winners, we run this, and actually I left this fixture quarter. It should be fixture semi or semi-final. I run, and now we know that the winner between Brazil and the Netherlands is going to be Brazil, and between France and Portugal is going to be France. So now let's do this one more time for the final. So it's the moment of truth. Now we can see who is going to win the World Cup. So here I write the fixture semi and then the fixture final. So the final is going to be between Brazil and France. I couldn't update the match between the losers of the semifinals, but that's not actually important. We only want to predict the winner of the World Cup, so this is not so important. The important thing here is the match between Brazil and France. This is going to be the final. After writing many lines of codes and implementing the Poisson distribution and many things, we're going to know now the winner of the World Cup Qatar 2022. So here I'm going to run get winner, and inside df fixture underscore final. So this is my function and I'm gonna run this. So after we run, we see that the winner is gonna be Brazil. So Brazil is gonna win France and is gonna win its sixth World Cup. So according to all the Poisson distribution and all the Python code that we wrote, Brazil is gonna win this World Cup. And that's it. So now we finish this project, and this whole project is actually a real world project that is going to help you deal with other advanced projects. So now you know how to extract data from websites using web scraping, how to clean data, also how to visualize the data, and how to create a basic model that can help you predict something like a football match. So now it's time for you to implement everything that you learned into your own project. And that's going to be a challenge for you. So good luck and congratulations on finishing this project.